For this lesson, we will be graphing a system of inequalities. If you look here, remembering from the past, in order to graph a line, you must know this equation of y is equal to mx plus b. In order to graph that line, we follow steps 1 and 2, and then we just draw a line. So first we start with graphing letter B. We then go ahead and from letter B, we count our slope. And now, once we draw our line, we have to go ahead and shade the top or bottom. So underneath the things to remember, all of these steps that we just discussed, this is just an example of shading one inequality, where notice everything below this line are the ordered pairs that would make the equation true. Well, let's go to our system of equations. And I have them done in 2 different colors because it will be easier to see when we're graphing our 2 inequalities. So we have the first one, y is greater than or equal to a negative 3x plus 3. So remember, when I have a greater than or equal to or a less than or equal to, when I graph the line, if it's a negative slope, it's going to be a solid line. If it's a positive slope, of course, it will go this way. When you have a greater than or a less than, when we graph the line, it will be a broken line, which means the answers that are on that broken line are not part of that solution. All right, so let's start with the first one. Y is greater than or equal to a negative 3x plus 3. I'm going to start by graphing my letter B right there. And again, I know the slope is going to be negative. It's going to go downhill from left to right. So I'm going to go up 3, 1, 2, 3, and over 1. Because remember, every whole number is over 1. And I'm going to go up 3 more, 1, 2, 3, and over 1. And I'll go down 3, 1, 2, 3, over 1, 1, 2, 3, over 1. And now I am drawing, because it has a greater than or equal to a solid line. That means that anything on this line is part of the solution. But now I have to see, do I shade the top half of this line or do I shade the bottom half of this line? And in order to do that, what I usually do is I pick a ordered pair that's really easy to check, and I'm going to pick my 0, 0. So I'm going to substitute in the values for this inequality. 0 is greater than or equal to a negative 3 times 0 plus 3. Well, 0 is greater than or equal to 3. Is that a true statement? 0 is greater than or equal to 3? The answer, of course, is no. So when you get a no, you can check another point, like I've shown you with our other problems, or you know that you're not shading where that 0, 0, that's false. So for this first inequality, I am going to shade the top part of the line. Okay, now let's go ahead and we're going to go to doing the other one, and the solution is going to be where the 2 graphs overlap. So we have y is less than or equal to x plus 1. I'm going to where the y-intercept is 1, and I am putting my point. And notice it's a positive 1 as the slope. So I'm going to go up 1 and over 1, and I'm just going to do that. Up 1, over 1, up 1, over 1. I like to have it filling my graph so I can really see where my solutions are. And I'm going to go down 1 and over 1, down 1 and over 1, all the way down the graph so I can make a nice straight line. And again, this is less than or equal to, so I am going to go ahead and I am going to make a solid line connecting my points that I have graphed. So I like to check that 0, 0 that I have right here marked, because if I get a true inequality for that, then guess what? I'm going to shade the bottom half of my purple line. So I am going to substitute in 0, 0 into this inequality, and I get 0 is less than or equal to 1 times 0, we know is going to be 0 plus 1. So is 0 less than or equal to 1? Oh, the answer is yes. That means where my ordered pair is, I now will shade it, and that is the bottom part of the line. And I'm starting up here, and notice I am doing all of my shading. So you will ask, well, what is the solution? The solution for this inequality is all of the double shaded areas. It is also what is on this purple line here. And it is also what is on this green line that we have here. Many solutions. Again, where your two inequalities overlap, that's where all your solutions are. So let's look at the second problem I have here. That has a little bit of a problem because it's not in y equals mx plus b form. So I am going to go ahead and I'm going to copy this inequality down below, 1/2 x minus 3 is greater than or equal to y. And we know we want it y equals mx plus b form. So, I'm just going to write my y over here, and I'm going to write 1/2 x minus 3 there. And notice how this is opening up to your expression here. So I know that I need to flip my sign so that it will indeed match where the top one opened up to. So let's go ahead and let's graph the green one. Y is less than or equal to 1/2 x minus 3. So I'm going to -3 for my y-intercept, and now my slope is a positive slope, so it will be going uphill from left to right, and it's going to be going up 1 over 2. Up 1 over 2. Up 1 over 2. And again, I like to go ahead and do that for a lot of the graphs so I can see where things are overlapping. So down 1 over 2, down 1 over 2, down 1 over 2. And I think that's probably good enough. So let's go ahead and again, go back to your symbol. The symbol is going to be, the line is going to be solid because it has that less than or equal to. Sorry about my lack of my straight line there, but you got the idea. So now I'm going to go ahead and I'm going to get the second inequality in y equals mx plus b form. Well, I'm going to copy it. So it's 2x plus y, let me move this one away, is greater than a 1. Well, I'm going to subtract my 2x. So I get y is greater than a -2x plus 1. Again, this is a negative, so I know that it is going to go downhill. And notice my symbol that I have here. It does not have the line underneath it. So my line that I'm going to be graphing is going to go downhill and it's going to be broken. All right, so now we're going to start at 1 where the y-intercept is. And we're going to go, remember it's always over 1. We are going to go, I'm going to do some on top, some on bottom. Up 2 over 1, I'm checking. Is that going to give me a downhill slide? That looks good. Up 2 over 1, up 2 over 1. Let's go the other direction. Down 2 over 1, down 2 over 1, down 2 over 1. Let's do one more. Okay. So now, I got to do one more. Down 2 over 1. When I'm drawing my line, remember, it must be broken. Those are our two lines. Now, we didn't check to see which is going to be shaded, the top or the bottom for the first one. So I'm going to, again, pick my ordered pair that I like, which by now you know is 0, 0. So here's my 0, 0 point, and I'm looking at my green line. So it's either going to go on the top or it'll be shaded on the bottom. So when I plug in a 0 here is less than or equal to 1/2 times 0 minus 3. 0 is less than or equal to a -3. Again, that's not true. So when I'm looking at my green line now, do we shade on the top where the 0 is? No, we got a false statement. So we know that we have to shade on the bottom of the green line. And here it is. Okay, well, let's go to our purple line that we have. Note, remember, we're going to check, and I love using that 0, 0. So 0 is greater than a -2 times x plus 1. Is 0 greater than our 1? No. Well, that's false. So for my purple line, I am not going to go ahead and shade on the bottom part where I'm kind of showing you now, because there's where my 0, 0 is. For my purple line, I've got to shade on the top. And when I do that, I can see here's my overlap. All of this is part of the solution. What also is part of the solution are the ordered pairs on this part of the line, the green line. What is not part of the solution are any ordered pair that would be on our dotted line. So again, when you're graphing a system of inequalities, in the end, you are looking for the shaded area of where they overlap. And those are your many solutions to your system of inequalities. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.